The use of artificial intelligence within the Australian defence sector is rapidly becoming a reality, with recent media releases showing autonomous targeting systems on both of the options for the new Australian infantry fighting vehicle, being the Lynx from Raytheon and the Boxer from Rheinmetall, as well as the Royal Australian Air Force using artificial intelligence in their search and rescue missions, just to name a few. As such, the conversation regarding the use of artificial intelligence within defence has shifted from whether we should to how we should ethically employ artificial intelligence within defence. Now, the Australian Defence Force Defence Science and Technology Group lists trust as a key facet to be able to achieve this ethical use of AI within defence. And researchers from the University of New South Wales, Canberra have stated that transparency is the overarching concept required to be able to achieve this trust using something called symbolic artificial intelligence. Which means that for AI to be ethically used within defence, they must be built with a trust architecture that is firmly based within the field of symbolic AI and that allows for transparency in the human-machine teamed environment. Hey guys, I'm Brandon, and today I'm going to be taking you through how AI is going to be ethically used in the future of warfare. Now, there are multiple ethical issues that can be associated with the use of artificial intelligence within defense, such as trust and reliability. How do you know the AI system is going to do what you tell it to do? Control and accountability. Who is accountable for the actions of these AI systems? And of course, motives and dignity. Is it even okay for an AI system to make possibly life-threatening decisions? The Defence Science and Technology Group gives us 5 facets to be able to deal with these issues, being responsibility, governance, trust, law, and traceability. And today's video is going to focus on the issue of control and accountability solved through the facet of trust. To start off with, we have to understand what AI is. And today we're going to be talking about symbolic and sub-symbolic AI systems. Symbolic AI attempts to reason about problems using high-level, human understandable representations called symbols. Generally speaking, symbolic AI uses knowledge graphs, which are essentially databases, to be able to link concepts through a web of interconnected nodes. And now this gives the system the capability to be able to semantically understand the issue that it is reasoning about. On the other hand, sub-symbolic artificial intelligence, such as artificial neural networks or deep learning, attempt to learn some function through often large data sources to be able to map the variables in a problem space using some function X goes to Y. Now, the key takeaway from this is that sub-symbolic artificial intelligence methods generate some output Y from some function F without having a clearly explainable or transparent process to be able to do that. And now this understanding of symbolic and sub-symbolic methods of AI poses a clear ethical issue with their use within defense. Can you trust an AI system that cannot inherently explain to you the process that it has come to a conclusion? If you'd like to know more on sub-symbolic AI systems or symbolic AI systems, I recommend this video here and this video here. Links for these will be in the description. In a 2016 UN report, it was proposed that autonomous weapon systems that require no meaningful human control should be prohibited. The International Committee of the Red Cross have also made their stance on this ethical issue quite clear, stating that we need to maintain human control over weapon systems and the use of force, both for legal compliance and ethical acceptability. Now, command is a mechanism through which the responsibility of the employment of any system can be asserted. And this relationship between command and responsibility is the basis upon which we can build and assign accountability. ADF doctrine states that command is the authority and responsibility for using available human and material resources, and goes even further to state that command is a fundamentally human function that cannot be conducted by machines. It provides accountability for ethical decision-making. The common theme shared amongst all of these 3 sources is that the control of the AI system must remain firmly under the human operator, and that this control then forces the accountability for the actions of that AI system back onto the human operator. The question remaining from these observations is, how do we exert control over a cognitive agent that may at some point become unpredictable but still function within the commander's intent and within the bounds of its regular functionality? In his book, Should We Ban Killer Robots? Spoiler, the answer is no. Baker poses that a high level of reliability is required for an AI system to be considered trustworthy. Baker goes on to reason that sub-symbolic methods used to generate exciting solutions to niche problems, such as the deep learning used to defeat the world's greatest AlphaGo player, may generate unpredictable results. Their ability to follow the intended task of the user maintains that trustworthiness with the user. This trust that is fostered through the reliable use of an AI-enabled system is what is used by the operator to exert their control and then assume the accountability for the actions of that AI-enabled system. Therefore, for an AI-enabled system to be controlled, it must be reliable. Now, what we have to remember is that these sub-symbolic AI methods are generated, not designed, by taking large data sets and feeding them forward through a neural network. Now, put plainly, what this means is that just like you or I, these sub-symbolic AI methods can become confused when exposed to new or challenging circumstances. An example of such a situation was realized when car maker Volvo trialled their self-driving car in Australia, only to have the animal detection system break due to the confusing hopping patterns of kangaroos. As sub-symbolic AI methods generate results without having a process of being able to explain how they generate these results, a serious ethical question is posed when they fail, which is, who is to be held accountable when they do fail? As explored before, these AI-enabled systems are controlled through trust, and this trust is fostered through the reliable operations of said systems. So, who do we hold to account when these systems fail when they had been previously held to be trustworthy? As detailed in their 2020 technical report, transparency within an AI system refers to an operator's awareness of an autonomous agent's actions, decisions, behaviours, and intention. And as the University of New South Wales Canberra research is stated in their 2021 report, this system transparency is the overarching concept required to enable a trust architecture to be constructed in the human-machine teaming environment. The way to achieve this transparency is to ensure that interoperability and explainability is enabled in these AI systems. And in their 2022 report, these researchers state that symbolic AI systems allow for this bidirectional information flow between humans and machines, which in turn ensures mutual understanding between both cognitive agents here and ensures a trustworthy relationship can be achieved that a commander can then use to exert control over an AI system and accept the accountability for its actions. In short, symbolic AI methods have the ability to be able to explain their decision-making process, achieving a greater level of transparency. This means that the commander of that AI-enabled system can then exert more control over that system and then accept more accountability for the actions that system takes. In his book, Should We Ban Killer Robots?, Baker poses a thought experiment to be able to illustrate that as long as AI-enabled systems are reliable, we have control over them. In this thought experiment, an AI-enabled loitering munition is fired from a 60mm mortar employed by its operator to hit a predefined target, utilizing an onboard autonomous target selection technology. To illustrate where this employment of AI would be furthered ethically through the use of symbolic AI, I pose an extension to this scenario. In this extension, the smart munition has the ability to send feedback to the operator and is employed within the urban environment. In scenario 1, we're going to use an AI system that only has sub-symbolic methods, and in scenario 2, we're going to use an AI system that has symbolic and sub-symbolic methods. Scenario 1, Sub-symbolic AI. A friendly call sign has come under fire from a well-hidden machine gun nest within the confines of a suburban district of a local city. A mortar man in the area has been tasked with suppressing this position with indirect fire to allow for a clean break. Given the rough grid estimate of the position, a mortar man deploys a smart loitering munition from her 60mm mortar and monitors the drone sensors for the target. The smart munition identifies the nest location at a local school, but due to the irregular jumping patterns of the children in the yard across from the nest, just like our kangaroos from earlier. This smart munition mischaracterizes the area as an insurgent training space. As such, the AI-enabled system places a large bounding box over the whole area and labels it as a threat, with those inside being insurgent forces. As the optics of the smart munition are not high enough in fidelity to make out the particulars of the people on the ground, and the use of these smart munitions have functioned reliably up until now, the operator has no reason not to trust the system and authorizes a strike on the local school. Scenario 2, Symbolic AI. Scenario 2 is exactly the same as Scenario 1 with the exception of an AI system employing a symbolic architecture. In this situation, the sub-symbolic AI system used to classify the enemy threat picture area mischaracterizes the school as an insurgent training area, placing a large bounding box over the area and labeling it as such. In this scenario, however, the symbolic system provides the operator with its reasoning for the classification. The symbolic AI utilizes its interconnected database to link the concept of irregular movement pattern with courtyard and building and sends the operator the message, "Unknown movement from courtyard indicates insurgent training area." The human operator, knowing that it's highly unlikely for the enemy forces to be training whilst the friendly call sign is in a contact, concludes that the system has mischaracterized the situation on the ground and moves to cancel the strike. This situation can then be utilized to provide the system with further training to mitigate the reoccurrence of a similar situation. In both scenarios, we can see that the AI-enabled system mischaracterized the situation on the ground. In scenario 2, however, we can see that the symbolic-enabled AI system allowed the human operator a higher level of control as it was able to explain its decision-making process. The ethical use of AI within the defense domain requires that control be exerted through a trust architecture, and this trust architecture be firmly grounded in transparency. This trust architecture is not a functionality that can be afforded by sub-symbolic AI methods. As such, for the ethical deployment of AI within the defense domain, these systems must be built with symbolic reasoning, which enables transparency and fosters trust in the human-machine teaming environment. This trust allows the human operator to exert a greater level of control over the AI system, which in turn allows them to accept the responsibility and accountability for the actions of that AI-enabled system. Put simply, you cannot trust a cognitive agent that cannot reasonably explain its decision-making processes, and as such, you cannot ethically use that agent within defense. Hey guys, thanks for watching the video. If you'd like to see any of the source material, then it'll be in the description down below. And if you'd like to know anything more on either sub-symbolic or symbolic AI methods, I'm going to leave some useful links to some videos in the description below as well.